大家好，这里是听广播学英语频道。你知道吗？冥王星不是一颗行星，但它为我们揭示了太阳系是如何形成的。这个节目讨论了冥王星的重新分类、行星形成过程、小行星带以及不同的行星定义。专家们主张冥王星在理解太阳系形成方面的重要性。好了，我们来听这个轻松有趣的话题吧。
You're listening to Shortwave from NPR.
Hey, Shortwavers. So as part of our Shortwave Space Camp series we're dropping every Tuesday, we recently asked you to tell us what's your favorite planet. And you called in from all over.
This is John Erickson, a retired planetarium operator from Richmond,
California.
My name
is Summer, and I live in Wheat Ridge, Colorado.
Mom, my name is Marina, and I live in Little Georgia.
You named a lot of good ones.
Saturn is a favorite planet of mine. It's got bright rings, awesome moons, and atmospheric waves that make a hexagon around the North Pole.
My favorite planet is Earth because we live here, and everyone I love is here. It is the only planet with dogs, and I have two dogs.
My favorite planet is Uranus because it spins sideways.
But the one you didn't name was Pluto. That's because Pluto isn't a planet. It's now a dwarf planet. In 2006, a meeting in Prague changed its fate forever. At the International Astronomical Union, 424 members representing over 1,000 scientists passed a resolution to decide what the word planet would actually mean in our solar system. And what kind of scientist would you call yourself?
Old.
That's Virginia Trimble. She's an astronomer and also studies the history of science. And she was there in Prague when the vote happened.
I was there as an ordinary IAU member. I also skippered the team of tellers who counted the votes. Everyone who was entitled to vote had a yellow card, and you voted by holding your yellow card up. And so the tellers came down the aisles counting the number of yellow cards were being held up in the row and doing basic arithmetic to get the total numbers.
Leading up to the meeting, multiple objects that were around the same size as Pluto had been found. So the IAU decided to reopen the question of what makes a planet a planet. They decided that in order to be a planet in our solar system, an object needed to meet 3 criteria. 1, it had to orbit the sun. 2, it had to be big enough to assume hydrostatic equilibrium, which is a fancy way to say it needed to be round. And 3, it had to, quote, clear the neighborhood around itself. Basically, to have a strong enough gravitational pull that there wasn't anything left immediately around it, like no asteroids or other small bits of rock or ice. And that third requirement, that's what disqualified Pluto.
At the time, I felt that something had to be done about Pluto. And with that, I mean that, Pluto was always the oddball among the planets.
That's Vladimir Lyra. He's a computational astrophysicist, and he says even though scientists made up the decision back in 2006, it's still kind of controversial now, depending on who you ask.
Planetary sciences used to be part of astronomy. Now, there is some mixing, of course, but by and large, we're talking about 2 different communities.
So the fate of a planet was being decided by people who don't study planets, mostly.
And that was and is still one of the criticisms about the vote. That astronomers, right, were voting on the definition of planet, and who study planets are planetary scientists. Right?
So today on the show, the case for Pluto. What it can tell us about how planets were created, and why are some planetary scientists still Pluto defenders almost 20 years later. I'm Regina Barber, and you're listening to Shortwave from NPR. Okay, Vlad, let's get into these discoveries that ultimately led to the vote in 2006 to demote Pluto. Like, first of all, there was Ceres in the early 1800s, and it was born out of this search for a planet in between Mars and Jupiter, which scientists kind of focused on because, like, the 4 planets closest to the sun are somewhat evenly spaced out until you get to Mars, and then there's this, like, big gap between Mars and Jupiter where there's this asteroid belt where there's no planet. And this perplexed scientists.
So the idea that there should be something there was already in the mind of astronomers. They found Ceres. It was heralded as a planet. But then they kept looking and kept finding more stuff they found more and more objects, nothing as big as Sirius, but Sirius was sharing its orbit with many other objects.
Right, and like initially they were calling like a bunch of things planets. It seemed at the time there wasn't really like a super clear distinction between planets and asteroids.
Right. So that led then to astronomers to rethink what these minor planets were, and then they were called asteroids.
So I guess there's like precedent for Pluto being like demoted.
As I said before, Pluto was always the oddball, right? It was seen that Pluto just didn't fit among the 8 planets.
And that was partly because of the dwarf planet Ares. Like it's in the Kuiper Belt with Pluto towards the end of the solar system, right?
Yes. When Ares was found, that was the catalyst to declassify Pluto, because all of a sudden you found an object that was more massive than Pluto, right? So either you also call that object a planet, or you have to rethink the definition of planet.
Okay, so let's talk about Pluto for a little bit. It was discovered by an American in 1830, not even 100 years ago. And after that IAU vote, it's not even a planet anymore. So why do you think Pluto is so fascinating, if you think Pluto is fascinating?
Oh, I think Pluto is absolutely fascinating for sure. Pluto holds many clues to understand how planets in general form. So as a scientist who studies how planets form, for me, Pluto is a brick that helps me understand the building.
Yeah, no, that totally makes sense. So let's just step back for a second, though, and like think about and talk about how do planets and dwarf planets like Pluto form in the first place?
Right, so the way that planets form is you start from a cloud of gas and dust. And modern astronomy has found these disks of gas orbiting young stars. And what we see is that once you have dust in a disk of gas, coagulation will take place. So you build larger grains out of the dust that is in this disk. A bit like if you don't clean your room often enough, you're going to get dust bunnies, right? Now imagine that you don't clean your room for 10 million years. Just how big those dust bunnies will get, right? So with that,
take the whole room.
Yeah. So with that, you form the first grains, right? The first dust grains. And then there are mechanisms happening in this disk that help concentrate these dust grains so that you get an object of the size of asteroids. We call these bodies planetesimals, which is a portmanteau of a planet plus infinitesimal. So a very small part of a planet. So asteroids and comets, they are these so-called planetesimals, or as I like to call them, the building blocks of planets, right? And then once you build it that size, gravity comes into play, and then they can keep growing to the size of the Earth.
That's so cool.
Or bigger, and at some point they get so massive that they attract gas from the disk and then form a gas planet like Jupiter.
Okay, which brings us back to our friend Ceres, right? The dwarf planet in the asteroid belt between Jupiter and Mars. It's got all these asteroids around it. Like, how come they haven't combined together and turned into a bigger planet?
So the asteroid belt did not become a big planet because of the presence of Jupiter.
Really? Okay.
Jupiter is a very massive planet, so the tides from Jupiter end up exciting the orbits, so that is much more likely that when two planetesimals in the asteroid belt collide, they're going to fragment, right? So that is the main reason why the asteroid belt did not become a planet.
Wait, so just so that I understand, so you're saying that because Jupiter is so big and because its gravitational pull is so influential on all of these asteroids, they make them move faster so that when they do collide, they smash instead of moving slower and just coalescing?
Correct. Yeah, we call it a dynamically hot population, right?
And is the Kuiper Belt similar? Like, is it also dynamically hot population, or is there something else going on?
So the Kuiper Belt is different, though, especially at the region where Pluto is. The number of objects per volume of space is just so low that they can go ages without finding another object. So these bodies just didn't grow large because they formed so far away from the sun. And also the density of other objects nearby is so small that they never meet each other. So they couldn't really grow. right?
Then how did Pluto get made then?
Right, that's
it's pretty
another
big.
point. Pluto is very big. Pluto did not form where Pluto is. Pluto formed at about half the distance where it is now and was put in its orbit by Neptune.
What? So this is kind of blowing my mind because you're saying that the definition of a dwarf planet is that it orbits the sun, that it's round basically, and that it cleared its path. But you're telling me that at one point maybe Pluto did have a cleared path. Maybe it wasn't in this belt.
Right. There is a very good point. And that's one thing that prompted planetary scientists, in fact, to use another definition of planet that they call the geophysical definition of planet. That depends only on the mass, right? So in that case, a planet is an object that has enough mass to be round. So that's only the second part of the IAU definition. And that makes sense for some astronomers, including me, because to me, right, and to to others too, it doesn't really make sense to define a planet based on one location. So if a planet has to clear the orbit to be defined as a planet, if you take Pluto and put it where Mercury is, Pluto will clear the orbit. So then Pluto, a Mercury orbit, would be a planet. You take Mercury, put it where Pluto is, it is not
a planet anymore.
So the geophysical definition of planets looks only at the intrinsic characteristic, right? And it boils down to just mass. That means that you have rocks, right? There are like asteroids, things that are not massive enough to be round. And then you have planets, which is anything that has massive enough to be round, but is not fusing inside. And then once you get big enough, you become a star, right? So there are rocks, planets, and stars.
This is so amazing. I had no idea. Okay, I kind of want to keep going because this is kind of fascinating.
Yeah, I can talk about Pluto all day long.
Then what's next? Like, what else can we find out about Pluto? What does that mean for its designation? Like, what's the future hold for Pluto?
What it means for the designation? Well, the IAU vote that was held in 2006, I don't know if it's being challenged, but definitely what is happening is that some people are not comfortable with the dynamical part of the definition, the clearing of the orbit, and planetary scientists have been advocating for a purely geophysical definition. In this case, Pluto is a planet. The moon is a planet, right? And one of the arguments that is being given by that is that, if we do that, then there's going to be too many planets. How are kids supposed to remember the name of all of the planets if we have so many? It's like, can you tell me the lineup of the U.S. women's soccer team?
No.
I don't know all names there.
Yeah, I don't either. But they're still pro soccer players.
Yeah, and so this argument, I think, that doesn't hold much water. So classification-wise, I am completely comfortable calling Pluto a planet, the moon a planet.
Europa, one of Jupiter's moons, is a planet?
Europa is a planet, yes, exactly. If you put Europa in an independent orbit around the sun, you would call it a planet.
100%, I would. Okay, well, thank you so much, Vlad, for talking to me today and making me really excited about Pluto.
My pleasure.
Thank you so much. Again, we'll be back tomorrow with our regular shortwave and back Tuesday with our next installment of the Space Camp series. And I have the sneak preview from one of our experts.
Hey, shortwavers, it's Dr. Serafina Nance, your supernova guide back on Earth. I hear you're getting to leave our solar system and are on your way to visit stars other than the sun. One of my favorites is Betelgeuse, and I'm so jealous that you might get to see it explode from space. In case you didn't know, Betelgeuse is a red supergiant fated to explode any day now. Take a selfie with Betelgeuse for me. Thanks, and have a blast.